In this lesson, we will begin by explaining the subnet mask. A subnet mask is a 32-bit number that masks an IP address. It separates the IP address into network addresses and host addresses. The subnet mask is made by setting network bits to all ones and setting host bits to all zeros. Within a given network, two host addresses are reserved for a special purpose and cannot be assigned to a host. The 0 address is assigned to a network address, and the 255 is assigned to a broadcast address. A subnet mask of 255, 255, 255, and 0 would convert to all ones, all ones, all ones, and all zeros in binary. Note the binary subnet mask values cannot interweave ones and zeros. The ones are on the left, and the zeros, if they exist, are on the right. To determine a prefix or slash notation of a subnet mask, count the number of binary ones in the binary mask, and write the total after a slash. For example, the following mask has 19 bits turned on, and would be /19. Again, please note the term prefix or prefix mask is also called a slash notation or CIDR, classless interdomain routing. The idea of subnetting an IP network is to separate a big network into smaller multiple networks for better organization or for security reasons. Performance in a network is strained when excessive traffic is on the network. Excessive traffic also leads to congestion on the network due to collisions and retransmissions. As we explore further into subnet mask concepts, it is important to understand how a computer determines the network ID of any given IP address. The following diagram illustrates how the computer performs a bitwise logical AND operation on an IP address with a given subnet mask. When we perform a bitwise AND, we compare two numbers which will either be a 1 or a 0. A 1 is considered to be true and a 0 is considered to be false. As we follow the diagram and read from left to right, you will see how the network ID gets calculated. A 1 and a 1 equals 1, or true. Again, we have a 1 and a 1, so we get true. Next, we have a 0 and a 1, so we get 0, or false, followed by a 1 and a 1, which is true. A 0 and a 1 is false. A 1 and a 1 is true. A 0 and a 1 is false. A 0 and a 1 again is false. A 0 and a 1 is false. A 0 and a 1 is false. A 1 and a 1 is true. 0 and 1 is false. 1 and 1 is true. 0 and 1 is false. 1 and 1 is true. 0 and 1 is false. 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 1 and 1 is true. 0 and 1 is false. 0 and 1 is false. 1 and 1 is true. 1 and 1 is true. 0 and 0 is false. 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 1 and 0 is false. 1 and 0 is false. 0 and 0 is false. And 0 and 0 is false. Now that you have seen how to calculate a network ID from a given subnet mask and IP address, please pause the video and take the time to practice these three problem sets. The network prefix identifies the addresses that reside in the same subnet. All IP addresses in the same subnet have the same value in the prefix of their addresses. Whereas the host range of an address identifies a host uniquely inside each subnet. It's important to note that the subnet mask defines a dividing line between the prefix and the host range. Wherever our ones stop and our zeros begin, it's called our network boundary. Now we will learn how to determine the number of available hosts on a given network. The number of hosts on a network is determined by the formula 2 to the h minus 2. In this example, we have 8 zeros. If we take 2 to the power of 8, we get 256. However, we have to remove the first and last addresses from the pool of usable addresses to accommodate the network and broadcast. Finishing the formula, we subtract 2 and we get 2 to the power of 8 minus 2 equals 254 usable IP addresses for hosts. hosts such as PCs, printers, or any other network device. We may not always need or want all available IP addresses using the default mask. In these cases, we can borrow bits from the host to create subnets, or smaller networks. This concept is referred to as subnetting, and it allows the mask and class to be divided into 3 parts. Let us explore some basic subnetting concepts. Here we have a Class C address. The default subnet mask for a Class C address is /24 or 255, 255, 255, and 0. We are borrowing an additional 2 bits from the host portion, making our network a /26 network. Subnets in the network are calculated with the formula 2 to the power of s, where s is the number of additional bits borrowed from our original Class C mask. As previously stated, we have borrowed 2 bits. Therefore, our formula looks like this: 2 to the power of 2 equals 4. This leaves 6 bits turned off for hosts. Remember, the formula for hosts is 2 to the h minus 2, which, in this case, 2 to the power of 6 minus 2 equals 62 hosts. As you can see, after we subnet, we get more networks with fewer hosts as opposed to less networks with more hosts. In this lesson, we went over the subnet mask and how the computer determines the network from the host by ANDing the IP address and subnet mask. We defined the prefix for CIDR notation. Finally, we introduced the concept of creating subnets, smaller networks, by borrowing or using bits in the host portion.